adding, subtracting matrices. We're going to perform some addition, subtraction, scalar multiplication of matrices. A matrix is a rectangular arrangement of number of rows and columns. So here's an example of a matrix. Okay. I could have a tall, skinny one like this, 1, 5, 3. There are 1, 2, 3 rows. So its dimensions, I would say 3, which is rows, and there is 1 column, so 1 column. So this is a 3 by 1 matrix. Another example here, it could be all sorts of different numbers. It could go 1, 0, 0, 0, 1, 0, 0, 0, 1. It has 1, 2, 3 rows, so 3 rows by 1, 2, 3 columns, so 3 by 3. Okay. Each element is any given spot in here. So if I were to say circle that is in row 2, column 2, that is an element. So it takes 9 elements to fill up my 3 by 3. It takes 3 elements to fill up my 3 by 1. Okay, that is kind of the idea of a matrix. It will come into play a lot when we get to 3 unknowns and 3 equations to solve for. For 2 matrices to be equivalent, they have to have the same exact value in their corresponding spot. So this is row 1, column 1. So in row 1, column 1, I have to see the same value. Now 5 halves is not the same as 2.5, but if you divide 5 divided by 2, you do get 2.5. Okay, here's row 1, column 2. So in row 1, column 2, I got the same number. Okay, row 2, column 1, row 2, column 1. So I'm going row 2, column 1 here. Both matrices are the same, 3's are the same. So I've got equal matrices. Okay, now these are both 2 by 2's, 2 rows, 2 columns. They have the same shape, but 1 and 0 are not the same, so these are not equal. Okay, so that's how you determine whether 2 matrices are equal or not equal. Okay. Addition. Okay, with matrix addition, it's basically adding corresponding spots. So in one matrix, I've got row 1, column 1, I got 0. Row 1, column 1, I got 1. So I'll take 0 plus 1 and eventually get 1. 4 plus a negative 9 to get negative 5. 3 plus 8 to get 11. Okay, I took a 3 row by 1 column matrix, a 3 row by 1 column matrix, added them together, and I got a 3 by 1 matrix. Okay, so it's adding a bunch of integers is what it is. Same thing with subtracting. Subtracting, I'll take 3 minus 2 to get 1. 3 minus 0 to get 3. 9 minus a negative 3 to get 12. Negative 5 minus 5 to get negative 10. Okay, I took a 2 by 2, another 2 by 2, added them together, or actually subtracted them and got another 2 by 2. And that's what I'm looking for. Now this is a 1 by 2 because there's only 1 row. And this has got 2 columns, 1 and 2. And this is a 2 by 2. I can't add these together or subtract because of mismatch dimensions. Okay? To add or subtract matrices, they have to be matrices of the same shape and same size. One other operation is called a scalar multiple. I like to think of this as the distributive property of matrices because what you're doing is you're taking a number that's on the outside of your matrix and you're kind of distributing it to all spots. So it's going to become 6 times 2. 6 times negative 3. 6 times 8. And 6 times 4. So left with 12, negative 18, 48, and 24. 2 by 2. This particular problem, I just want to stress this: you're still going to follow the order. Please excuse my dear aunt, Sally. PEMDAS, order of operations. So here I would multiply out first, and I'll do one spot just to kind of show you what I'm talking about. So I would take negative 1 times 4 first, and then add 3. So that first spot's going to end up being -1. Now I've got a 3 by 2 matrix and a 3 by 2 matrix, so this will end up by a 3 by 2 matrix. And you can multiply the rest of those out and figure that out. So I'm really trying to do that to figure out this. Okay, I want to solve for x, and I notice that x here is in row 1, column 2. So I need row 1, column 2, row 1, column 2, and all of the operations with it to come up with that. So simplify the parentheses, I get -2x, take it times 4, and I got -8x equals -48, and solve that, and I get x is +6. Okay, now with y, that's in a different spot. So if y is in this spot, these are the numbers I'm interested in, along with, of course, the operations. So now it's for 2y plus 6 equals 8. And I picked those spots because I had row 2, column 2. I need to pick all the numbers in row 2, column 2. And this time I got to distribute because I didn't have like terms inside the parentheses. 8y is equal to -16 divided by 8. Get y is equal to -2. So that is operations with matrices, adding, subtracting, multiplying. There's no such thing as division, and in fact, we'll talk about a different multiplication later.